today Group 8 from Section 41 code SSCE1793. In this video, we are going to discuss about application of partial different equation in. Before we start, let me introduce my fellow group members. Firstly, we have Wang Shihian with matrix ID A21EM0279, Isa Muhammad A20EM9126, Amira Zinat A19EM3005, Nur Shuhada Sabri A21EM0194, and me myself, Wan Nur Shazrin Shafika A21EM0249. Without any ado, let's get into the video.
Hi, this is Amira Zinat. So now I will discuss about my topic. So the first question is, what is partial differential equation? A partial differential equation, or simply a PDE, is a mathematical equation involving two or more independent variables, an unknown function depending on those variables, and partial derivatives of the unknown function with respect to those variables. A partial differential equation solution is any function that solves the equation in the same way. A universal solution is one in which the order of the equation is equal to the number of arbitrary independent functions in the solution. Partial derivatives are important in examining surfaces for maximum and minimum points, and partial differential equations are formed because of them. A rate of change or the slope of a tangent line is represented by a first partial derivative, much like conventional derivatives. The elimination of arbitrary constants or arbitrary functions can produce partial differential equations. By eliminating arbitrary constants or arbitrary functions, partial differential equations can be generated. The second question is, what are the methods used to solve partial differential equation? The finite element method, FEM, finite volume techniques, FVM, and finite difference methods, FDM, are three most extensively used numerical methods for solving partial differential equations, but there are other mesh-free methods that were developed to handle issues where the methods are constrained. The next question is, what are the applications of partial differential equation? Physical and other issues involving functions of several variables such as heat or sound propagation, fluid flow, elasticity, electrostatics, electrodynamics, and so on, are solved using partial differential equations. Vector calculus and differential geometry both employ partial derivatives. A partial derivative of a function of many variables is its derivative of one of those variables, while the rest are kept constant in mathematics, as opposed to the total derivative in which all variables are allowed to vary. The last topic is to give the example of applications of partial differential equation. Various applications, there are actually various applications which are used in partial differential equations. So among them there are continuum mechanics, gas dynamics, hydrodynamics, heat and mass transfer, wave theory, acoustics, multiphase flows, chemical engineering, and so on. Use such equation. Because of variety of sources, there are many different forms of partial differential equations, and methods for dealing with many of the individual problems have been devised. So these are all the examples of applications which are used in partial differential equation.
So today I will tell you guys about the problem statement. So let's move on to the question. So this is the question. So the question is, a tightly stretched string with fixed endpoints x equal to 0 and x equal to L is initially in a position given by y equal to y0 sine pi x over L. If it is released from rest from this position, find the displacement yxt. Let the equation to the vibrating string be. So this is the equation. So the equation is del power of 2y over dt power of 2 equal to c power of 2 del power of 2y divided by del x power of 2. And initial condition are y 0t equal to 0, y lt equal to 0. So this is the condition 2. So del y over del x equal to 0 at t equal to 0. And then y x0 equal to y0 sine power of 3 pi x over L equal to y0 3 sine in bracket pi x over L minus sine in brackets 3 pi over L. So my friends will tell you how to finish this question.
Good afternoon to my dear daughter and my friends. My name is Huang Xisian, and today I will show one example of the application of partial differential equation in vibration of string by using the wave equation to solve. Now we list out the initial condition first. So this is our initial condition. They are given by the question, and we write down all the info. And from here we can know that sine cube theta equal to 3 sine theta minus sine 3 theta divided by 4. So we will get this. And after this is our general solution. Y equal to C1 cos ms plus C2 sine ms multiplied with C3 cos CMT plus C4 sine CMT. So now we use the first condition to solve this equation first. So when s equal to 0, y will be equal to 0. So we will put 0 at here, and when the s equal to 0, our sign will be equal to 0. So we just left the C1 on the in front of here only, and this is our. We just write down C3 cos CMT plus C4 sine CMT. So from here we can know that C1 will be equal to 0 by compared to with the both sides. So our solution, our equation will become y equal to C2 sine ms multiplied with C3 cos CMT plus C4 sine CMT. And now we use the second condition to solve. So we put y equal to 0 and C2 sine ml and multiply with C3 cos CMT plus C4 sine CMT. So from here we can know that we cannot use the C2 to become to 0, because when C2 equal to 0, our whole equation will be equal to 0. So we just can use sine ml to compare with the left side. Firstly, we know that sine m pi equal to 0. So we compare with them. We will get ml equal to n pi, and m will be equal to n pi divided by l. So now our equation will become C2 sine n pi s divided by l, C3 cos cn pi t divided by l plus C4 sine cn pi t divided by l. So now we are going to be partial differentiate it with respect to t, so that we will get this C2 sine n pi s divided by l, and when we differentiate, the cos will become negative sine. So we will get this, and when we differentiate the sine theta, we will get cos. So we use the two condition to solve, which is del y divided by del t equal to 0 at t equal to 0. So this will become to 0, and our C2 m pi s divided by l, and multiply with 0, because when t equal to 0, this whole will become to 0. And when we put t equal to 0 on here, cos 1 will be cos 0 will become 1. So we will get C4 multiplied with n pi c divided by l. So we compare with the left side and the right side we will get C4 equal to 0. So after this, our new equation will become y equal to C2 sine n pi s divided by L multiplied with C3 cos n pi ct divided by L. So now we just assume that C2 equal to C3 equal to Bn. So we will get y equal to Bn sine n pi s divided by L cos n pi ct divided by L. You can write in this form y equal to summation of n equal to 1 to infinity Bn sine n pi s divided by L cos n pi ct divided by L. So as before that, y equal to y naught divided by 4 multiplied with this at t equal to 0. So we can just use this equation to find our Bn here. So we will get y naught divided by 4 and his other on the left side. So we compare with them. You can know that when n equal to 1, our B1 sine pi s divided by L. So we will get this, and when we compare, we will get B1 equal to 3y naught divided by 4, and B2 equal to 0, B3 equal to negative y naught divided by 4, and B4 equal to B5 equal to 0. We just compare them from here, and this form is not equal to here, so we will let B2 equal to 0. So therefore our equation will become y equal to summation of n equal to 1 to infinity Bn sine n pi s divided by L cos n pi ct divided by L. So we put our B1 when n equal to 1, B1 sine n pi s divided by L cos pi ct divided by L plus 0, because B2 equal to 0, so we put 0 plus B3 sine 3 pi s divided by L cos 3 pi ct divided by L. Y equal to 3y naught divided by 4 sine pi s divided by L cos pi ct divided by L minus y naught divided by 4. From here we cannot. So sine multiplied with sine 3 pi s divided by L cos 3 pi ct divided by L at last. This is our final answer for the y in function of s with t.
Thank you, Wang. So in conclusion, partial differential equations are used to mathematically formulate and aid the solution of physical and other problems involving functions of several variables. So partial differential equations plays a major role in application of science and engineering, and it arises in wide variety of engineering applications. For example, propagation of heat, sound, fluid flow, electrostatics, electrodynamics, and of course wave equation. So we thank you so much for your time. We really appreciate it.